Good afternoon. Thank you for joining me for lesson 2 of Unit 9. Today's lesson is going to continue on with looking at parallelograms. I have the learning goal for the lesson written down on the whiteboard behind me on a post-it. I know it's a little challenging to read, but I will read off it slowly, and then the PowerPoint that I'll send you has this as well as the objectives. I'm going to go over the guided practice, some of the theorems, and different types of problems that we are going to be looking at. And then also I will go over some independent practice. So today's lesson is again on parallelograms. The learning goal is that students will recognize the conditions that ensure a quadrilateral is a parallelogram and determine their properties. So as I stated, we're just going to continue on with what we learned, some of the properties that we learned in lesson 1. And I will be sending you a informal assessment to allow you to kind of look at lesson 1 and determine if you are getting the concepts. And then for lesson 2, I'm also going to send you a student self-assessment that has you really reflect on the learning of this section, as well as letting me know some of the things that you struggle with and how I can help assist you further. So we're going to be looking at lesson 2, the guided practice. I'm going to do number 1, 2, 4, 5, and 7, and I'm also going to be looking at the independent practice. I'm going to do number 9 and 10, and then 15 and 16. There will be some independent practice that I definitely need you to work on your own, and basically just watch this YouTube video. If you have any questions during class, we can address those, but let's begin. So the guided practice starts on page, it's 817, so page 817, and I believe the independent practice stops on 819. So looking at page 817, we have basically problem 1, and it has a parallelogram that has bisects running through it, and we have 25 degrees right there, and this angle is 23 degrees. And it says determine whether each quadrilateral is a parallelogram. So if we look on page 813, we kind of went over these theorems last time. So if we look at page 813, there are certain properties that we can look at a quadrilateral to determine if it is a parallelogram. And one of the properties that we had only looked at the basically the bisects right here. It would show that these two portions of this segment of the parallelogram are congruent, and then these two would be congruent. When you are drawing a line segment from one opposite basically angle of the parallelogram to the other side, or from this vertice to that vertice, etc. So when we look at this, this basically tells you that these two segments are congruent and these two segments are congruent. That means, again, we have opposite angles that are going to be congruent from each other as well. We determined that last time looking at the properties of parallelograms in lesson 1. When we look at this portion right here, this angle is 23 degrees, and this angle right here is 25 degrees. So are these two angles, even though it's a section of an angle, are they congruent? Whenever we have a line going through and it bisects, it basically creates two equal portions. So that means that this section right here is 23 degrees, this angle, and this portion above it is 25 degrees. So are these two opposite angles congruent? And the answer is no. So the question asks us if this is a parallelogram based on the properties. And this quadrilateral is not a parallelogram because it doesn't satisfy any of the tests that we learned in the last lesson to determine if it is a parallelogram. Because these opposite angles are not congruent, just like in this diagram that I had, it is not a parallelogram. So looking at number 2, we have, it looks like a rectangle with two opposite sides that are congruent. And if we remember, there was an example from lesson 1 that we did about a property that says if the opposite sides of a quadrilateral are congruent, then it would be classified as a parallelogram. So if we look at these opposite sides of this quadrilateral, they are congruent. So this would be a parallelogram. Yes, this is a parallelogram. Because we used a property that we learned from page 813. That's a key section. It tells you the different components, the different tests that we can apply. There's 4 diagrams to determine if a quadrilateral is in fact a parallelogram. And because it actually is a theorem where if the opposite angles in this example or the opposite sides in this example are congruent in a quadrilateral, then it is in fact a parallelogram. So let's look at number 4. So number 4 is very similar to some of the problems that we looked at from lesson 1. Number 4 has a parallelogram with 2 different variables. And we have x and y basically. So we have 5y plus 14, and we also have 7y. So I am going to look at that right now. Interesting. Okay, so it's literally the same type of problem that we did from lesson 1. So I'm going to use this example. Since it is the same type of problem and number 5 actually is looking at angles that are opposite in a parallelogram, I'm going to skip number 5 because we went over this material in the first lesson, lesson 1. So it says find x and y. So the property that we used in lesson 1, it's from page 813, and I just discussed, it says that the opposite sides of a parallelogram are congruent. So since we have 4x plus 4 and 8x minus 4, we can actually set them equal to each other and solve for x. So that's one of the equations that we're going to solve for. So we want to get x on one side of the equation, or the equal sign. So I'm going to subtract 4x to the other side. And I'm going to get 4 equals 4x minus 4. And then finally, I'll just move it to the other location. Even though I like to deduct it in order, I just want you to see the full steps. So we're going to add 4 to both sides to get the number on one side of the equation, or the equal sign, and the variable on the other. So we have 8 equals 4x. So lastly, we're just going to divide by 4. So x equals 8 divided by 4, which is 2. So x equals 2. We're going to do the same thing for y. Since we solved for x, we're going to set, because these two sides are congruent based on that property we learned about in lesson 1. So we're going to have 5y plus 14 equals 7y. We're going to subtract 5y to both sides of the equal sign, and that's going to give us 14 equals 2y, and then we're going to have 14 equals 2y. We're going to divide both sides by 2, so y equals 14 divided by 2, which equals 7. So we just solved for x and y. X equals 2 and y equals 7. But I think what they want you to do, actually they don't, but I think the property, if you were to plug in 7 in for y, you would have 49 right here, because 7 times 7 is 49, and then 5 times 7 is 35 plus 14 is 49. So these sides are actually equal, and we could do the same for x. If we plugged in 2 into 4x plus 4, we get 12. 8 times 2 is 16, minus 4 is 12. So this side is 49, this side is 49. This top portion is 12, and the bottom portion is 12. So we're just extending on problems that we learned in lesson 1. And so now I'm going to move on to the last question of the guided practice. I'm skipping over 5 because it's the same type of concept. But number 7 is a new concept that I want you to know and understand. It's very important in mathematics. And it has to do with basically, I believe, using the slope formula to determine the slope of each side of the parallelogram, or the quadrilateral to determine if it is a parallelogram. So number 7 has a quadrilateral, and the quadrilateral has a side like this, and we have side J that is, or point J, that is -7 and 1. We also have point G right here that is -1 and 2. We have point F right here that is -5 and 3. And we also have H, which is at -3 and 0. So when you look at this problem, you're going to notice something. The book kind of messed up a little bit, because it says that G's at -1, 2, but then it drew J, which is at -7 and 1,